Hello students, today we are going to solve many problems related to the hydrocarbon chapter. These problems are related to the topic which we have covered in the hydrocarbon, that is alkanes, alkenes and alkynes. So let's start. Now first we start discussing the problems which are related to alkanes, that is first hydrocarbon. So first question is written on the board. Devise a scheme for the synthesis of n-butane using methyl iodide as the only carbon source. So according to the first part of question, we have to synthesize n-butane, CH3, CH2, CH2, CH3. This is n-butane. What do you mean by n-butane? It means the straight chain of butane. We have to synthesize n-butane from methyl iodide. So this is the first part of the question. What is second part of the question? Can you employ the reaction in your scheme to synthesize propane in fairly pure state? So in the second part of the question, it is asked that can we apply the similar method which is used for the preparation of n-butane? Can we use same method for the preparation of propane, in which the propane will be obtained in pure amount, just like as butane? So second part of the question is, can we prepare propane from methyl iodide by applying similar method of preparation which is used in the preparation of n-butane? So let's see. So first part of the question, in this methyl iodide, that is 2 moles of methyl iodide are taken in the presence of sodium and dry ether. You know that this reaction is Wood's reaction. So in the presence of sodium and dry ether, these methyl iodide will react with each other and there will be formation of CH3, that is ethane will takes place. In this case, there will be removal of 2 NaI. This sodium will react with the iodine, so there will be removal of 2 NaI. So what is happening in the next step? This ethane will react with chlorine in the presence of sunlight, or we can also use sulfonyl chloride. So this can also be used in the presence of peroxide. This is peroxide. So this reaction is taken place by the help of free radical mechanism. So what is happening? There will be formation of CH3, CH2, Cl will takes place. So further this ethyl chloride will react in the presence of sodium and dry ether. This is Wood's reaction. This is Wood's reaction. What is happening in this case? There will be formation of CH3, CH2, CH2, CH3, that is n-butane will takes place. So what is happening in this step? 2 moles of ethyl chloride will be taken in the presence of 2 sodium and dry ether. This is Wood's reaction. So there will be removal of NaI will takes place, 2 NaI, and formation of these 2 ethyl will join with each other. So there will be formation of n-butane will takes place. Next part of the question, can we apply the similar method for the preparation of propane in the pure state? In this, first of all, we take methyl iodide in the presence of sodium and react it with ethyl iodide. In the presence of dry ether, Wood's reaction will takes place. What is happening in this case? This reaction, that is Wood's reaction, is not suitable for the preparation of unsymmetrical alkane, because in the case of unsymmetrical alkane, 2 different alkyl halides are taken. Because of that, there will be mixture of products are obtained. So let's see how many mixture of product will be obtained in this case on the product side. In this case, this methyl iodide first of all react with itself. So there will be formation of CH3, that is ethane will takes place, and this ethyl iodide will also react with itself. So there will be formation of CH3, CH2, CH2, CH3 will takes place, that is n-butane. Further, these two alkyl iodide react with each other. So there will be formation of propane will takes place. So in this case, there is mixture of products are obtained by the help of Wood's reaction when two different alkyl iodides are taken. And why it is a drawback for this Wood's reaction? Because there is a difficulty in the separation of these mixture of product by fractional distillation. Because the boiling point of all the alkanes which are obtained in the product side is almost same, due to which they cannot be separated by the help of fractional distillation. Question related to alkanes is how will you prepare a pure sample of propane? We know that we cannot prepare a pure sample of unsymmetrical alkane by using Wood's reaction. It is not suitable for unsymmetrical alkane formation, whereas it is suitable for the preparation of symmetrical alkane. So which reaction will be useful for the preparation of unsymmetrical alkane? That is Corey-House synthesis. We have studied Corey-House synthesis in the case of, that is in the preparation of alkanes. In this case, we take one alkyl halide, that is ethyl bromide, in the presence of lithium and dry ether. So there will be formation of CH3, CH2, Li, and removal of LiBr will takes place. 2 moles of this ethyl lithium in the presence of copper dry ether, there will be formation of Gilman reagent is taking place, that is CH3, CH2, Cu, CH3, CH2, Li. This complex, in this complex there will be positive charge on Li and negative charge on this complex. This is Gilman reagent which is formed in the first step. What is the name of this compound? This is lithium diethyl copper. So what is happening for the formation of unsymmetrical alkane? We have to take alkyl halide which is different from this alkyl halide. So what is happening? Methyl bromide. So there is electronegativity difference between the carbon and halogen. This bromine is having partial negative charge, carbon is having partial positive charge. So because of this electronegativity difference, this carbon is electron deficient, due to which this carbon, that is this ethyl, will attack on this carbon. So this bond will be shifted towards this carbon. So what is happening? This ethyl will attack on this carbon, so there will be formation. This reaction is occurring in the presence of dry ether. So there will be formation of propane will takes place, and byproducts are CH3, CH2, Cu, LiBr. So these are two byproducts, that is ethyl copper and lithium bromide. So there will be formation of unsymmetrical alkane, that is propane is taking place. Next question related to alkane is what happens when butanoic acid is heated with soda lime at 630 Kelvin? Is there any other acid which also give the same product under similar condition? Write its name and reaction involved. So in the first part of the question, there is asked what happens when butanoic acid is heated with soda lime at 630 Kelvin. We know that this is a decarboxylation reaction. So let's see how the reaction will take place in the first part of the question. So we have to take butanoic acid. So in the presence of NaOH, in the presence of calcium oxide, and temperature of the reaction is 630 Kelvin. This is given in the question. So this mixture, that is NaOH plus CaO, this is known as soda lime. So what is happening in this case? There will be decarboxylation will takes place. It means there will be removal of Na2CO3. So what is happening? descent of series will takes place. It means the carbon which is obtained, that is hydrocarbon which is obtained in the product side, is having one carbon less. Because of that, this is a descent of series. So in the second part of the question, it is asked, can we use a different acid for the preparation of this propane by the help of decarboxylation? So let's see. In the second part of the question, we can take CH3, CH3, COOH. What is the IUPAC name of this compound? Numbering will be done from this position, 1, 2, 3. So this is methyl 2-methyl propanoic acid. This is 2-methyl propanoic acid. So let's see in this case whether the preparation of propane will takes place or not. So in the presence of soda lime and temperature is 630 Kelvin, so there will be decarboxylation will takes place. It means the removal of Na2CO3, that is sodium carbonate. So there will be formation of propane will takes place. This reaction is also descent of series. So in this case, we can take either of the two acid for the preparation of this propane by the help of decarboxylation. Next question related to alkane is, give the structure of product that is X in the following reaction. So in this case, this is the reactant. So let's see how the reaction is taking place. So what is happening? So in the presence, in the first step, this reactant will react with Mg. There will be formation of Grignard reagent will takes place, that is RMgX. So what is happening? MgBr, benzene ring, CH2, CH3. So this is a Grignard reagent, that is RMgX. In this case, halogen can be any halogen, that can be chloro, bromo, iodo, whether R represent either aryl group or alkyl group. So what is happening? This is Grignard reagent. So this Grignard reagent will react in the presence of D2O, that is deuterium oxide. It will react with deuterium oxide. So similar reaction will takes place as shown by H2O. So what is happening in this case? There will be splitting of, that is ionization of this molecule will takes place as it takes place in the case of H2O in the presence of H+. There will be splitting of H+ and OH-. Similarly, in this case, there will be splitting of D+ and OD-. So what is happening? This H+, that is D+, will attack on this carbon of this benzene ring, whereas this OD- will attack on this Mg. Because in this case, there will be electronegativity difference between the carbon of this benzene and this magnesium. There will be positive charge come on this magnesium and negative charge will come on this carbon of the benzene ring. Because of that, it is behaving as a carbon ion. So it will attack on D+ part, whereas this magnesium which is having positive part is attacked by this OD-. So what is happening? There will be formation of, first of all, write the byproduct. Byproduct will be MgODBr. This will be byproduct, and the product which will be formed is CH2, CH3. So in this case, in this position, there will be attachment of this D+ will takes place because this D is having positive charge. Now we will discuss the problems which are related to alkenes. So first question, dehydration of alcohol to alkenes is always carried out with concentrated H2SO4 and not with HCl or HNO3. So what is happening? First of all, write the reaction. So in the case of concentrated H2SO4, what is happening? When we take alcohol, so this H2SO4 will release H+ ion. So what is happening? In the presence of H+ ion, there will be formation of CH3, CH2+, because there will be removal of H2O will takes place. How H2O is removed? Because this electrophile will attack on the lone pair of oxygen. Because of that, there will be formation of OH2 will takes place, and the positive charge will come on this oxygen. So how this formation is taking place? This CH3, CH2, OH, H, when H plus is attacking on this alcohol, there will be formation of this protonated alcohol will takes place, and positive charge will come on this oxygen. And you know that the positive charge on oxygen is unstable. Because of that, this bond will be shifted towards this oxygen, so there will be positive charge will come on this carbon. Because of that, the positive charge is coming on this carbon. First of all, you have to know that dehydration of alcohol takes place by the intermediate, that is a carbocation. So in the presence of concentrated H2SO4, what is happening? This hydrogen will give away its electron, that is shared pair of electron will be shifted towards this carbon. So there will be formation of double bond will takes place in the presence of concentrated H2SO4. So there is removal of H plus ion is taking place. Whereas in the case of HCl, what is happening? In the case of HCl, HCl will also dissociate, that is ionized to H plus and Cl minus. So first of all, electrophile will attack, so there will be formation of this protonated alcohol will be taking place, and further there will be formation of carbocation is taking place. So in this carbocation, further nucleophile will attack, which is obtained from the ionization of this HCl, and we know that Cl minus is very good nucleophile. Because of that, this will attack on this carbocation. So there will be formation of CH3, CH2, Cl is taking place. So why this similar reaction is not taking place in the presence of H2SO4? This HSO4 minus is a non-nucleophile. This is non-nucleophile. It is not a good nucleophile. Because of this negative charge is resonating within the molecule, due to which there is high conjugation is taking place within the molecule. Because of that, this negative charge is not available for donation, due to which there will be formation of ethene is taking place. Because this is a non-nucleophile, that is SO4 minus, whereas this Cl minus is a good nucleophile. Because of that, it is easily available for donation, so it will attack on this carbocation, so there will be formation of ethyl chloride will takes place. Whereas in the case of HNO3, when this ethyl alcohol will be reacted with concentrated HNO3, there will be formation of oxidized product is taking place. It means the oxidation of this product will takes place, because HNO3 is very good oxidizing agent. Because of that, instead of formation of ethene, there will be formation of aldehyde will takes place. So there are many strong acid whose negative part is not behaving as a good nucleophile, that is they are behaving as a non-nucleophile. Example first is H2SO4, and second is H3PO4, and also KHSO4. This is some example of a strong acid whose negative part will not behaving as a nucleophile. Next question in alkenes, dehydration of 1-butanol or 2-butanol with concentrated H2SO4 always gives the same mixture of 2-butene and 1-butene. 2-butene will be 80% and 1-butene will be 20%. So in this, the first part of the question, it is said that both reactant, that is 1-butanol and 2-butanol, give same mixture of product with a similar percentage of composition, that is 2-butene will be 80% and 1-butene will be 20% in both the cases. So first of all, let's see in the first let's see the reaction in the first case. So what is happening? If we take 1-butanol, CH3, CH2, 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 OH. This is 1-butanol, and second condition, second reactant is 2-butanol. CH3, CH2, CH, OH, CH3. So this is 1-butanol and this is 2-butanol. So what is happening in the first case? If we take 1-butanol, So there will be, first of all, in the presence of H plus, first of all there will be formation of protonated alcohol will takes place, because this H plus will attack on the lone pair of oxygen. Because of that there will be formation of OH and positive charge will come on this oxygen. Because of that the bond between carbon and oxygen will move towards this oxygen, because we know that oxygen is second most electronegative. Because of that it is less stable. When positive charge is coming on the oxygen it is less stable, due to which this bond will be shifted towards oxygen. So there will be removal of H2O will takes place and formation of carbocation will takes place. This is primary carbocation, and we know that 1 degree carbocation is not that much stable. Because of that 1,2 hydride shift will takes place. This is 1,2 hydride. What is happening in this case? In this case the hydrogen of this carbon, so if we represent the open structure, so what is happening in this case? 1,2 hydride shift is taking place. This hydrogen will move towards this carbon. So there will be formation of 2 degree carbocation is taking place. This is more substituted carbocation. Because of that the stability of this carbocation is more, due to which there will be formation of 2 product will takes place. In this case there will be removal of H plus will takes place, and this H plus can be removed from either of the carbon which is next to this carbocation. So these are the beta carbon which is next to the carbocation. So the hydrogen can be removed either from this carbon or it can be removed either from this carbon. So because of that there will be formation of 2 type of alkene will takes place. This hydrogen which is present on this carbon will be removed and donate its electron to this position. So there will be formation of double bond will takes place in this position. This is 2-butene. Hydrogen will also be removed, can also be removed. So there will be formation of double bond will takes place on this position, due to which the second product which will be obtained, that is CH2 CH double bond CH2. So there are 2 products. This is 1-butene. So in the first case it is said that 1-butanol or 2-butanol both give same mixture and same percentage composition of 2-butene and 1-butene in the reaction mixture. So let's see, in the case of 2-butanol what is happening. So in the presence of H plus, first of all there will be formation of protonated alcohol will takes place. Because of that oxygen will be having positive charge, so the carbon oxygen bond will be shifted towards the oxygen. So there will be formation of secondary carbocation will takes place. It means the positive charge is coming on this carbon. So in this case also, in this case there will be no need of 1,2 hydride shift, because in this case as it is a secondary carbocation is formed, but further when there is H plus ion will be removed from either of the carbon which is next to this carbocation. So there will be mixture of this product can be formed. So in this product there will be formation of 2-butene and 1-butene will takes place, but the major composition will be of 2-butene will takes place, that is 80%. Whereas 1-butene will be in less percent. So either of the 2 alcohol can be taken, and in both the case when the dehydration will takes place, so there will be mixture of products are obtained and the composition is also same. In the second part of the question it is said that in the case of 1-bromobutane there is dehydrohalogenation is taking place and the major product is 1-butane. Whereas in the case of 2-bromobutane, when dehydrohalogenation is taking place, the major product is 2-butane. So in this case, there is different major products are obtained. So let's see how the reaction is taking place in this case. First of all, in 1-bromobutane. This is 1-bromobutane. So dehydrohalogenation is taking place in the presence of alcoholic KOH. So what is happening? There is positive charge on this potassium and negative charge on OH. So in the presence of this OH minus, this hydrogen, this is beta hydrogen, the halogen is present on the alpha carbon, and this carbon which is next to this carbon, this is beta carbon. So what is happening? The hydrogen of the beta carbon. So if you represent the open structure, so what is happening in this case? In the presence of OH minus, this nucleophile is initiating the reaction, that is dehydrohalogenation. In the presence of OH minus, there will be protonation will takes place. It means the shared pair of electron will be shifted towards this position, whereas this Br will be removed. So what is happening? There will be removal of HBr will takes place, and formation of CH2. There will be formation of double bond will takes place between the CH double bond CH2. This is 1-butene. So in this case, this is the major product. No other mixture of product is present in this case. So if we take 2-bromobutane, so in this case, as you can see, the bromine is present on this carbon, so this carbon will be referred as alpha. There is 2 beta carbon are present which are next to this alpha carbon. So there will be two ways by which dehydrohalogenation will takes place. Either this hydrogen of this carbon will be removed, or either can be this hydrogen of this carbon can also be removed. So there will be formation of mixture of product will takes place. So what is happening? If this hydrogen will be removed, if we represent the open structure, what is happening in this case? In this case, either this hydrogen can also be removed and this hydrogen can also be removed. So if this hydrogen give its electron, so there will be removal of Br minus will takes place in the presence of alcoholic KOH. So what is happening? Removal of HBr will takes place. So there is two condition by which the dehydrohalogenation can takes place. Either this hydrogen can also transfer its electron. So there will be formation of mixture of product is taking place. If this hydrogen will be removed, so there will be formation of double bond in this position, 2-butene, and this is more substituted. Because of that, this will be major product. It is about 80% in composition. Whereas if this hydrogen will be removed, so there will be formation of CH3, CH2, CH double bond CH2. This is 1-butene and this is less substituted. Because of that, the lesser composition will be of this alkene, due to which it will be 20%. So because it is less stable, it is less substituted. In the case of bromobutane, that is 1-bromobutane, there is formation of major product is 1-butene. Whereas in the case of this 2-bromobutane, there is a major product, that is 2-butene.